Welcome to Session 2, Object-Oriented Concepts, Relationships, Collaboration, and System Structures. In this session, we will look at the object-oriented designs and understanding the relationship between objects. Association defines how objects interact with each other. For example, students take courses and professors teach courses. Association helps identify and describe those relationships, including the number of objects involving and the optionality of the interactions. In modeling association, using unified modeling language, a thin line connects two classes, depicting their level, role, cardinality, directionality, multiplicity, and qualifiers. For example, a student may take one or more seminars. Seminar may be attended by 0 or more students, and the student acting as a teaching assistant may assist in 0 or more seminars. Those relationships help clearly define the roles and responsibility of each object in the systems. Aggregation and composition further describes part of relationships. Sometimes objects are composed of other objects. For example, an airline made up of fuselage, wings, engines, and landing gear, or a delivery shipment containing one or more packages. Composition is a stronger form of aggregations, where the whole is completely responsible for its parts. For example, an engine is always part of one specific airline. In unified modeling language, aggregation is shown with hollow diamond, while composition uses a solid diamond. Both types clarify multiplicity and roles, such as an item being part of only one shipment or an employee being part of one or more teams. Collaboration occurs when objects interact by requesting information or actions from each other. For example, an airline collaborates with its engines to fly. Those interactions are carried out through messages, which can be requests for actions or informations, and are modeled in unified modeling language sequence and collaboration diagram. Persistence is another key concept, focusing on storing objects permanently. This includes saving the values of objects and maintaining their relationships, along with retrieving or deleting them as needed. Objects can be persistent, like stored customer record, such as temporary editing screens. Coupling measures the degree of interrelation between classes or methods. Loosely coupled classes interact without knowing each other's internal implementation, while highly coupled classes depend heavily on each other. High coupling can increase maintenance difficulty, so it should generally be minimized or carefully documented. Cohesion, by contrast, means how focused a class or method is on a single responsibility. Highly cohesive methods perform one specific task, like enrolling a student in a course, while highly cohesive classes represent only one type of object. This approach improves maintainability and clarity in system design. Polymorphism allows objects to take multiple forms. For example, John Smith's object might be a student, a registrar, or a professor. The system can treat objects of different types uniformly, sending message without knowing the object's specific type, and each object will respond appropriately. This flexibility enables dynamic behaviors within systems. Interfaces define a collection of operation signatures that classes or components must implement, ensuring standardized behaviors. For example, a student class may implement serializable and searchable interfaces adhering to required method signatures. Components represent modular extensible units with specified interfaces and dependencies. They should be modular, containing everything needed to fulfill responsibilities. Extensible, allowing enhanced and open operating across platforms and interacting through defined interfaces. Component diagrams help visualize those relationships and the structures of larger software systems. By understanding those concepts, developers can design flexible, maintainable, and well-structured systems that model real-world relationships effectively. Thank you for watching. In the next video, we will move to Chapter 2, Object Orientation, the new software paradigm.